In this video, we are solving a problem basing on the concept of beats. Let me read out the problem for you first. A tuning fork of frequency 288 Hz. One frequency is given for you. When sounded with an unknown fork, gives 4 beats per second. Let us stop there for a while and try understanding what he meant to say. There are two forks producing beats. You know the number of the beats. We have derived a formula as N1 difference N2 is equal to 4 beats per second. Now we don't know whether N1 is higher or N2 is higher. One N1 value is given for you, 288 H. Difference of N2 equal to 4. But we don't know who is higher, N1 is higher or N2 is higher. So there are two possibilities, right? What are the two possibilities? If 288 is greater than N2, our equation will be 288 minus N2 equal to 4. Or the other possibility, if N2 is greater than 288, our equation will be N2 minus 288 equal to 4. Hope you got it here, right? It is given that the difference between them is 4, but we don't know who is higher, whether 288 is higher or N2 is higher. Number of the beats is N1 minus N2 is number of beats per second. So the higher value has to be taken as a first value, N2 has to be a lower value. So there are two possibilities that occurs here, right? Now, if N2 is larger, then I have to write this equation. So among these two equations, who is correct, I don't know. Basing on that, our answer will change. To find out that who is correct, he has given further conditions. When the unknown fork is loaded with a little wax. So what happens when you load with a wax? That's the first point I want you to understand, right? When loaded with wax, mass of that N2 becomes more. As mass increases, its frequency decreases. It couldn't able to oscillate normally. So as we have loaded with wax, frequency of N2 decreases. So here, either in this case or in this case, when you load with wax, that N2 decreases. What happens then in our problem? Number of the beats is reduced to 2. Earlier number of the beats are 4. Now it was reduced to 2. Now let us analyze both these equations, this equation and this equation, in which case reducing the number of bits to 2 is a valid phenomena, right? Let us start with the first case itself. Yeah, this case. In this mathematical equation, there are two terms. You are keeping the first term fixed and you are reducing this as you have loaded with wax. So in any mathematical equation, if you keep the first term fixed and if you reduce the second term, the difference between them has to increase, isn't it? You have, for example, 1000 minus 400 is equal to 600. Now you keep 1000 fixed, you reduce this 400 to 300. Now it becomes 1000 minus 300, it becomes 700. So the number of the beats has to increase, but it is given that the number of the beats are reduced to 2. So this case is not a valid case in our given problem, because if this is correct, when waxed, number of the beats are supposed to increase, but in our problem number of the beats are reducing. So this is a wrong option here, we can't use this. And let us check this option also anyway to be on the safe side. Here this second term is fixed, we have loaded this with wax, so its frequency decreases. So in any mathematical equation, the same equation I will take. If I keep the second term fixed like this, if I reduce the first term, say from 1000 to 900, then the difference between them is 500. It is reduced from 600 to 500. In our problem also, as it is given that the number of the bits are reduced to 2. So the given condition, the what is given for us, is being satisfied here. This is correct. So what we can understand here is this is a right equation here. Sorry, this is the right equation here, and this is a wrong equation here. So this equation is valid. From this I can write what I can write. N2 minus 288 is 4 is correct. That implies N2 is 288 plus 4. That is 292 H. So in the first case, the problem is having an answer of 292 H. Anyway, to analyze further, one more problem I have taken. What is that? If the unknown fork is sharpened a little, so that the number of the beats again reduced to 2, what's the frequency of that fork? So I will start analyzing in the same way, nothing different, right? So the number of the two beats are there, two frequencies are there. So 288 difference N2 is 4. There are two possibilities. If 288 is larger, 288 minus N2 equal to 4, or if N2 is larger, N2 minus 288 is equal to 4. Who is right? We don't know. To verify that, it was given that when the unknown fork is sharpened little, what happens when you sharpen? When you sharpen fork, its mass reduces, it is able to oscillate more comfortably, so its frequency increases. So let's assume this is the first case. Who is correct? So in both the cases, 288 is fixed, but N2 is sharpened, so its frequency increases. So let's start analyzing this case first. In this case I want to analyze. In any mathematical equation, if you keep the second term fixed and if you increase the first term because you are sharpening, the difference between them has to increase, isn't it? I will take the same example. 1000 minus 400 equal to 600. Now the second term is fixed, you have sharpened this, so its value increases, says to 1100. So 1100 minus 400 becomes 700. Number of the bits has to be increased to higher value, but it is given that number of the bits is 2 or reduced by 2 so that it becomes 2. Both are same. That implies here it is increasing, but in our problem it is said it is decreased. So this option is not a right option. This is the wrong option in our given data. Let us check with this case. Keeping the first term fixed, if you sharpen this, its frequency increases. Increase the second term. What happens? I'll take the same example. 1000 minus 400 equal to 600. You keep 1000 fixed, but sharpen this so its mass decreases, its frequency increases from 400 to 500. Say for example, just for a simple number. Now the number of the beats the difference is reduced from 600 to 500. In our given data also, it was given that the number of the bits are reduced. So this is the right answer. This is the possibly correct answer. So what we can say in this? 288 minus N2 is 4 is a correct answer. So N2 is 288 minus 4. 284 is the answer, right? Be careful in solving this kind of questions. These are very important and very simple, and they need a simple logic to understand it. I want you to go through this question once again, relook into the entire video once again, and if you have anything to ask, please comment in that video further. I will have a look into that, right? Thank you for watching. This problem, simple problem, explains everything about the tuning forks and bits problems. Be careful and look into that once again. Thank you.